Hello everybody. In today's video, we are talking about airline price analysis, and I just picked airlines for a couple of reasons. I think it's interesting. We're going to do some screen scraping, which is a very popular topic. I'm going to discuss that a little bit, and I think we can do some pretty cool, pretty fun, and interesting and useful things here. Now, this is just an example, like all these other videos I'm making. You can certainly take in and any kind of data, almost whatever you can think of. Your only limitation is your own imagination. You can do pretty much whatever you want. I think you just need to figure out what you're trying to do and then find out the way to do it. So in this video, we're going to focus just on airline analytics. We're going to look at travel information, different airline carriers, some policy making decisions, economic indicators, travel industry trends, and a few different topics that are related to this. So here is the URL. I copied and pasted it over here so you can see what this thing looks like. Basically, just Google travel information. Here's the airline carrier, the duration of the flight. So this is going from LaGuardia to San Francisco, one stop in Orlando, and then you have the cost of the trip, right? And you have, I think, some more information down here. You have a little more information, layover time, things like that. So you do have some pretty interesting data to work with. That's it. That's the basis of it. So let's get into it. So we're going to be using Selenium web drivers, which are very popular and useful type of tool for doing dynamic web scraping. And basically, Selenium acts like a person, whereby you can copy information, scrape it, interact with the web browser, clicking buttons, navigating through different web pages, zooming in, zooming out, things like that. So Selenium gives you a lot of control, just like a person would interact with a web browser. Selenium can do all the same functionality too. So this first part of the script, I'm going to share this when I post the video. This file is going to be posted in HTML format. You can download it and open it, and you'll have access to all the code here. You can copy and paste it, run it in your own Jupyter notebook. The first thing I'm doing is taking the entire HTML from this URL that I just showed you and saving it as a text file, webpage.txt. You don't have to do this, but I think it's kind of helpful, especially if the page is complex, to open it and to be able to view the HTML and a text file, and it helps you to get the relevant data points that we're searching for, like departure date, arrival date, airline, times, duration, the price, like I just showed on that webpage. So all of that is embedded in the HTML, and I think it's useful to read it as a text file. So once you don't have to do that, but if you choose to, I think it's a little bit easier than just reading the HTML in the browser. If you read the HTML, you'd have to go back here, hit F12 to get let's see, remember open dev tools, yeah, to get the HTML. And I think it's just a little bit more convoluted to do it this way, but everything is embedded in that page in different HTML elements. You can see it all there. You have to drill down into these different subsets. So I think just when you save it as a text file, it's a little bit easier to use. That's why I did it that way. So once you have the HTML, you can start to look for different web elements. They're called CSS selectors, cascading style sheets. That's CSS. And then you would look for a button on this page. If you go down here, let me close this view right here. If you go down here, scroll down a little bit, you can see this button. That's a CSS selector. So we're going to get Selenium to click on that. Again, just like a human would, the Selenium can automate all of these interactive steps for you. Once you click that button, then you're going to have all the flights exposed. I think there's about 200 or so data points on this website. So that's the button click event. If you don't do that, you're only going to get about maybe 12 or 14 or so different data points for flights, right? We really want to click that button, expand the page, and then we can see everything. Once everything is exposed, it's going to make for a richer, more useful data set rather than just a dozen or so. But yeah, you do have to do that. I think Google does that because not everybody has access to high-speed internet, Wi-Fi, or whatever like that. Some of the people using some websites are going to have just slower access to data. And it could take quite a while for the page to load up. I think that's why they do that. They just load the first few data points as a header rather than loading the entire thing. And you see that on different websites. Zillow uses that all the time. Other websites use that a lot, right? So once we click the button, we can see the different CSS data points, right? Here's CSS selector SQWE. And if I go over here and search for that, that is going to be the airline. I'll take a second to show you how that works. So here's the airline over here, United. If I click on this and go to inspect, I right clicked and clicked inspect and go over here and mouse over that, we should see that highlighted. Yeah, there it is right there. So that is actually the airline, and the duration of the flight is going to be the next piece over here. So right click inspect, and again you mouse over it and you can see the details there. So that will correspond to this over here. So these are text elements embedded in the HTML, and they'll have little codes. This doesn't necessarily make sense all the time. This one doesn't make any sense to me. It's dot, small s, big H, QWE. That's actually the airline name. Departure time is more, seems to have a more relevant name. Departure time is more meaningful. Arrival time is more meaningful. This one is duration of the flight, GBKRD. So this is kind of a cryptic code over here that Google uses. And price is data -GS with square brackets. Anything within the quote. If I go back here, let's see if we can see that one up here too. Price is going to be right here. Let's go here. Inspect. And there's the price right here, right? $398. So all of these are going to correspond to these HTML elements. Some have useful names that are somewhat meaningful. Some are kind of cryptic. And that's just the way they do it. Google uses a lot of cryptic code. So let me go ahead and run this. Control Enter will run the cell. Control Enter will run it, and once the screen scraping is done, we're going to see the results printed out directly below. And this is useful for the first time, I think, just to print it so we have a visual idea of what's happening. But when you just print this out as text, it's not going to be useful for doing any kind of plotting and charting. That's what we ultimately want to do. So we're going to screen scrape this into a data frame and prepare it in more meaningful columns and rows so we can work with the data. Okay, so it's building a list to print everything. So that's very helpful. We have all the data here, the prices, the duration of the flight, the airline, dates, and so on and so forth. So that's great. But again, I want to get this into a data frame. So I'm going to rerun. Most of the code is exactly the same with the screen scraping, but instead of printing, you can see the print statements down here. I'm not going to use these print statements. I'm going to load everything into a data frame, and this is going to be aligned very nicely in terms of columns and rows, a little bit like you would see in a table in a database or in a spreadsheet like Microsoft Excel, where you have the columns going across the top and rows going up and down on the left-hand side and right-hand side too, I guess. So I think the column and row format is very useful to work with. You getting data prepared, cleaned up, and presented in a way that's going to be easy to interpret for the user, very easy to understand. And then, of course, for all the plotting and charting, we're going to be creating a bunch of charts later just to understand the data and see how everything flows together. So once you get this into a data frame, it's going to be a lot easier to work with than just a printed out statement, right? Like it's going to be easier just to look at visually, to see those columns and rows, and then to create all the charts and plots based on those columns and rows. So this data frame is coming together right now. We should see something spit out pretty soon, and we're going to move on to the next step. I tested all the code beforehand just to make sure everything runs. And again, I will load this file when I load the video, so you'll have all the code. You can copy and paste it, do this yourself, and it's already set up pretty dynamically. So you could use any kind of data source. You have to understand the screen scraping part of it, but you can do this for any website. I do have a couple more videos I'm working on very soon, and it's going to be reintroducing the concept of screen scraping. I think it's very useful, very practical, and there's so many use cases for this. Like anything you see on the internet, pretty much almost anything can be screen scraped. Every website is going to be slightly different from every other one, right? So you have to understand the general concept. But once you have that down and you can figure out, okay, the CSS element is this code right here. You would look at the code on that site and see that, and then you see this code element and this code element. That pattern repeats itself over and over, and you're doing find by selector. So the only thing that's going to change here is this code right here between the quotes. That's the only thing that's going to change. Sometimes you'll see situations like, okay, so the prices might not be displayed over here, so you'd have to do more of like a try and accept. If they don't have a price listed, then there's nothing to screen scrape. The code could drip and fall down, and it would just stop running, right? So you would do a try and accept. But I think I only saw a couple of these where you have to try it. All the other data points are filled in. So if something's missing and the code is going to get tripped up, you do have to have this try accept statement over here. But if everything is filled in fine, then it's pretty straightforward. You would just grab that text. Okay, let's go down here. I think this is done running now. We can see the data frame that's put together. So it looks very nice. We have the departure date, arrival date. Everything is aligned. Pretty easy to read format over here. And we have the duration of the flight and the prices too. Okay, so that's great. Let's go down here a little bit more. Now we're going to create some plots and charts so we can do what's called EDA, exploratory data analysis, and visualize how this data looks. So in this case, again, I'm going to share all the code with you. I'm going to post this. You can download the HTML file and just double click, open it, and it's going to load into a web browser just like this. The view is going to be exactly the same as what you see here. So you can see United operated by Republic is the least number, the lowest price, and then the prices increase a little bit. Frontier, United, this is sorted in ascending order, right? So I get that from right here, sort values. All right, so we're just loading the data frame into this chart after we've sorted in ascending order. And then you see American, what's this? American operated by Republic. I'm not sure what that is. Alaska, Delta, and then we have a couple more airlines. So you can see visually, like this is the most expensive over here, operated by American Eagle, up to $700, and these are the more economic flights down to $400 by DBA, United Express. Okay, so that's pretty useful. We can see the distribution of flights costs over time. So one actually goes up to $1,200. One flight is up to $1,200, and the cheapest looks like it's about maybe $300 is the cheapest. And it's actually quite a few. There's like 25, and I think there's one flight that's close to $1,200. What's it say? Oh, $1,180 over here. So we see the max. The minimum is $194. The max is $1,180, right? So probably flying a much greater distance, right, than this guy over here. This is probably just a shorter flight, and some of these longer flights are going to be more expensive, right? But maybe they're operated by premium airlines, and maybe some of these people are getting like first class or business class tickets too, right? So the distribution of prices is pretty much all over the place. Then we go down here, we have a scatter plot of times of departures bin. So we have, I'm looking here at the price and then the departure time. I thought maybe if you fly early in the morning, 5 a.m., there might be a discount, but not necessarily. Some of these early morning flights are pretty expensive, $900, but it goes down to like, I think this is almost $180, $200, and then later in the day, $1,600, $1,700. So this is 4 p.m. and 5 p.m. The last flight within this data set is 5 p.m. Now we know flights depart after 5 p.m. all the time, but just in the data that we captured from that screen scraping exercise, the latest one is 5 p.m. And it really doesn't matter what time of the day you're flying. The prices could be close to $200, or they could be close to 1,000, and then one is actually over 1,000. So I'm assuming that's business class or some kind of privilege class for that for that kind of flight. So this is interesting. We've seen some plotting and charting of the flights, and again, the distribution is kind of all over the place, from cheap to very expensive, and the time of the day really has no impact on the cost of the flight. It's just scattered all over the place, right? There's no correlation between those. Now we see arrival time and departure time. We are trying to do feature engineering to create new features because this feature set is kind of sparse, right? If you have a very rich set of features, you can have dozens or hundreds of columns of data. If it's very, very sparse, it's going to be maybe just 4 or 5 columns of data, right? And you have to create new features from your existing features. So this is a feature engineering exercise. So you have the original dates, airline, departure time, so on and so forth. Now we have departure seconds, departure bins, duration minutes, arrival hour, duration hour, I think. Yeah, okay. So we've created just a few new features from the pre-existing features, and we're going to do a quick machine learning exercise here, a random forest regressor, to try to predict price based on these independent variables over here. This is duration minutes, duration hour, and arrival hour. We're going to try to predict the price and see how accurately we can do that. So the R squared is actually negative 0.32. A good R squared would be 0.9, high 0.8s, that's 80% accurate. High 0.9s, maybe 95, 99% accurate. That's what we'd like to see. This R squared is actually negative. And I was a little bit confused when I saw this. I kept it in here just for the demonstration purposes. Sometimes you can have a negative R squared. Usually if you square something, it becomes positive in the mathematics world. But in the statistics world, that is possible. Normally it's from 0 to 1, where 1 is a perfect fit and 0 indicates no fit. There's no correlation. But according to some Googling articles, I Googled some articles and found out that if the R squared is negative, that could happen. It's rare, but this could happen. It's just a really, really bad model to be using. And the dependent variable just is not being predicted at all, right? Or I'm sorry, the independent variable, sorry, I said right the first time. The dependent variable is not being predicted. The dependent is the y right here, and that's dependent on these independent features, right? So the x is the independent and the y is the dependent. So the model just kind of sucks. We're not going to be able to use it, and that's fine. We're just looking at plotting and charting in this exercise. I thought maybe we could predict price based on some of the features that were given to us, but we really can't do that. So at this point, the flights data is all over the place. So I'm going to bin these into night, morning, afternoon, and evening. So we're going to have 4 different bins. So 0 to 6 a.m. is going to be one bin. 6 to 12 is another. 12 to 18 is another, and then we have 18 to 24 as the fourth, right? So we have these 4 bins: night, morning, afternoon, evening. So this is what the data looks like. I'm going to go ahead and do counts to understand how frequently we're getting mornings, how frequently we're getting afternoons and evenings, and so on and so forth, and then plot that. So this is the data over here. Night, we have a few flights, not too many. Most of these are in the morning. 80 plus flights, probably about 90 total flights are in the morning. Oh, here's the actual day. 92, we have 44, 58, and then afternoon, 58 from the afternoon, and evening we had 0 again. I think the data set is not comprehensive. It's just coming from this Google Flights data. Probably we would need to go back and like do a more comprehensive screen scraping exercise, but that's fine. We're using what we've got, and this is all the data we've got. So we've got some nights more afternoon, and the most frequent time to fly is morning. Again, we're binning the data, looking at the duration of flight. So we have long, medium, and I think high. Long, medium, short is probably the binning sequences over here. Yeah, short, medium, and long. So some of the flights, only 2 in this case, are short. Most are medium, and then we have a few long flights too, and this is the graph of all these, right? So it's pretty interesting. I did not know that just by looking at these flights over here, that only 2 flights are short, most are medium, and 40 something are long, right? If you just oh, here's one of the shorts. I can guarantee this one of the shorts, 50 minutes, right? But there's only two of those. When you just look at it visually, you don't necessarily see that. That doesn't jump off the page. But when you plot it, it's a lot easier to present this story to your audience, right? If you're making a presentation or something, this is going to be much more captivating than this over here, right? Nobody necessarily wants to look at that view, but I'm happy to look at this view right here. Okay, so we have the flight timing, low, medium, and high, and again, these come from the bins over here of prices, right? Low, medium, and high prices, right? So we know that some are high. One is almost $1,200. Some are low. We saw, I think, 180 was the lowest price. So these are the prices plotted out. So that's pretty interesting. Here we have, again, counts by airline. So Alaska, I didn't actually sort this, but that's okay. If I had to do it over, I'd probably sort this. So most of the flights, looks like it's United. American is probably the second most common, and Delta is going to be number 3. Actually, yeah, you know, I think we did have something similar right at the beginning here. If we go over here, I think we had kind of the same thing. The number of prices, right? Okay, so moving on, we've got this all useful, very high sense of utility, usefulness of the data. Here's the average of all the prices. The mean would be the average of the airline prices. You can see the average prices here, somewhat stable. It goes from like maybe 300 or so up into, for this airline, this is probably the highest average American operated envoy, right? And it kind of swings in between. This one's kind of high too. But you can see the averages are pretty somewhat similar. But the highs and the lows are all over the place, right? You have some very expensive flights and some very cheap flights, but the averages are kind of just average, right? It's just right in between. Here, we're almost done here. We're doing counts of airline by hour, and then you have departure time, number of flights. That's kind of useful too. And then you'll have the market share overall out of 100%. What does this airline, American, covers about 24, almost 25%, so almost a quarter. Delta is at 19%, almost 20%, so that's 1/5. And United has most of the market share, about 36% of the market share. So that's it, just doing some pretty interesting analytics on airline pricing. And then once you have this data, you can do other things too. We did not have this in our data set, but it'd be useful to do demand forecasting, understanding you know, how many people need to fly, where they're going, how they're traveling, things like that. We can do price optimization. We can compare prices. Route optimization. Are all these routes optimized? Are they? If we had the longitude and longitude coordinates, we could do. You know, how accurate are these planes in terms of like the shortest distance between airports, or are they deviating a lot due to weather? All kinds of interesting analysis we can do on this airline data. So that's pretty much it, guys. Hope you got something out of that. Hopefully you learned a thing or two. I will post all this sample code when I post the video. You can download the HTML file, double click it, open it, and you'll see exactly the view I'm seeing right here. You can copy and paste it, and it's going to run perfectly fine for you. So that's it. Thanks for your time today. Have a great day, everybody. Bye.